All right. Next, we are going to talk about dependent events. Now, dependent events are what it says here is events where the occurrence of one event has an effect on the occurrence of the other. And I think that's a fancy, well, it's not a fancy way, but it's maybe a simpler way. It's saying if the first one directly impacts the second one in some way. And generally speaking, it's in the number of available outcomes. All right. So I think when we do this example, you'll kind of see where it's different from the other one. So in the other one, we had the raffle tickets. We had the two separate raffles. So it's very possible that, not necessarily likely, but it's completely possible that the person could have won one or the other, and they would have had no bearing on each other, right? So with this case, we'll see where they do actually impact each other. So it says Andrea randomly selects two cards from a standard deck of 52 cards, one right after the other without putting the first card back. All right. What is the probability that the first card is a heart and the second card is a diamond? All right. So the way this works, right, is first of all, you got to understand how cards work. So cards work, the way cards work is you have ace, and then, you know, 2, 3, 4, blah, 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 blah. And then it goes up to, once you get to your 10, and then you have jack, queen, and king. And that's kind of the hierarchy of cards. And sometimes they'll play aces high, you know, and sometimes aces low. It doesn't matter. But either way, from ace to 10, that's 10 cards, and you got another 3. So you have 13 different numbers of cards, right? And then you have 4 suits, all right? And your suits are, you know, hearts, diamonds, clubs, and spades. All right, so those are your 4 suits that you have available to you. Okay, so that means that you have ace through king in all 4 of those, which, so you just go 13 times 4, and you realize, and most of you know, that there's 52 cards in a deck. So that's why there's 52. Okay, so if you didn't know that, now you know. And so the probability of pulling a heart is, well, if a heart is one of 4 suits, right? That means that if you have ace of hearts, 2 of hearts, 3 of hearts, 4 of hearts, right? So there's 13 possibilities out of 52, which not surprisingly simplifies down to 1/4. Okay, now you could have figured that out by saying, well, I know hearts are one of 4 suits and they're evenly distributed, so you could have just gone straight to 1/4, but either way, you're going to get there. All right, so you have 1 in 4 probability that you pull a heart. So you have decent chances, 25% chance that you'll pull a heart. Now the second card is a diamond. You're going to be really tempted to say, oh, well, that's also going to be 1 in 4, and so you do this, and you go, oh, and you get 1/16, right? No, that is not what happens here. And the reason that's not what happens is because the deck changes after you pull that first heart. So if you do pull that first heart, right, you now, so that's draw 1, right? Now on draw 2, you now only have 51 cards. Okay, because 1 is out. It says without putting the first card back. So you now only have 51 cards. So because of that, you instead have a 13 in 51 chance, which is, you know, which is a slightly better odds than if you would have put the other card back, right? Because there's 1 fewer card to select and 1 fewer wrong card to select, right? Because you don't want another heart, you want a diamond. So now, because this works this way, when you do your multiplication for your dependent event, you're going to go 1/4 times 13 over 51, right? And so you're going to get 13 over 204, which is going to give you an approximate, you know, it's slightly lower percent than what you were going to get before, right? Is it close to what you would have gotten? Absolutely. Yeah, it's very close, right? We're splitting hairs here. But if you're talking about other cases, it's not as close as you think. So this gives you about 0.06, all right, which is another way of saying 6%. So you have about a 6% chance. We'll put the 3 here. So let's say a 6.3% chance. All right. So that is your probability. Probability is 6.3% or 0.063, depending on how they like it written. Usually on these, I think we'll go out to two digits, right, with our rounding. So hopefully that makes sense. And we'll see you in the final video, the final teaching video.